Hello, this is John from caveofprogramming.com. In this tutorial we're going to talk a bit about libraries in C++ because in the next program, hopefully in the next tutorial, I want to show you how to set up a program that can work with graphics in C++. But first we need to understand what we need to actually obtain in order to get that to work, and we need to understand a bit about libraries in C++. So in C++, you can, if you create a bunch of code, you don't have to create a program with that code. You can also create a library. If you create a library, you can then give that code as a compiled binary library to other developers together with the header files, and they can then link that code with their program and use it. So I've kind of touched on it before, although I haven't gone into compilation in explicit detail. But when you compile a C++ program, first the preprocessor runs, and that processes your anything that begins with a hash, basically. So your include statements, your if-defs. You can also have a define statement in there, which we haven't used, and so on. After the preprocessor, you then have compilation, which produces object files. So your source files, your CPP files, are compiled into object files, which produces files that usually have the .o suffix. I'm trying to think if that's the same for every platform. I think it is. So if we look at, let's just look at a program here. So if I get the location of this program that I've got here, and then we just go to that in the terminal here. So I'm on a Mac here, but it doesn't matter. Let's take a look. So I do cd, and I'm going to have to put this in double quotes. If we go to the debug folder, the folder for the debug target here, and we go to that's got a source subfolder, we see that we've got a bunch of .o files here. We've also got these debug files, but the most important thing are these .o files, which, as far as I can think, is also the same on Windows. So when you compile your program, you produce a bunch of .o files, and then the final stage of compilation is that you link your program. And linking means you combine all of your .o files together with any libraries that you have into an executable, which could have a suffix .extra on Windows, or no suffix on, for example, Unix platforms. There's no particular executable suffix. So when you link your programs, when you link those object files together containing your code, you can also link them with external libraries that you've used to develop your program. And if you think about it, even if you create a hello world program, let's say, you're using more code than you've actually written yourself there. You're using, for example, the code associated with cout, and that has to be contained somewhere on your system in order to be able to run it. There has to be code that actually deals with the console and outputs your text. And a C++ program will actually use libraries, which we call dynamic libraries, that contain that code. So let's take a look at how this works. When you compile a program, you've got a choice between using static libraries and dynamic libraries, and you'll be using some dynamic libraries kind of implicitly anyway. So static libraries, or static link libraries if you like, they are files containing C++ code which are actually compiled into your program. With an important caveat which we'll go into. So a static library is a bunch of C++ files that have been compiled the code's being compiled into a binary file, which we call a static library. And the idea is you give that binary file to other computer programmers. They can then link their program with it to create their executable and then use the code that was compiled into that static library. We can also have dynamic libraries. So we can have libraries that contain code which the program finds when it actually runs. So not when it links, but when it actually runs. And if you use cout, your program's going to use code in a standard dynamic library that's already going to be present on, usually at least, on any systems where that program is capable of running. So in this case, with dynamic libraries, your program will find the relevant code at runtime. So we've got those two kinds of libraries. Now, with static libraries, the actual files containing that C++ code, so the actual libraries, will have a suffix of, on Windows, .lib. So we have, for example, xyz.lib. That would be an example of a Windows static library. And you can create those yourself if you want to. It's not at all difficult to do. But I won't go into that in this tutorial. And on Unix type systems, so on Unix or Linux, they have a suffix .a usually, and they also start with the prefix lib usually. So we'll have, for example, xyz.a. So that's a Unix or Linux static library containing actual C++ code, which you can compile into your program and use. It's also the same on the Mac. Although I'm going to develop this program that I'm going to show you on a Mac. I'm actually going to use the Unix/Linux type system because I couldn't get the kind of Mac way of doing things to work with SDL. But the Mac system, OS, the Mac OS, is based on Unix in any case now, so we can use a Unix or Linux type system to develop programs with it, which makes things a bit easier. But as far as I know, in the Mac, static libraries also have a .a suffix, or at least you can use that kind of library on the Mac anyway. Now, dynamic libraries, dynamic on Windows. Let's put a hyphen in here for consistency. There we go. So on Windows, they have the suffix .dll. So you'll have xyz.dll. I don't use Windows anymore, but in the past when I programmed Windows, at least it used to be the case that you have a lot of DLLs in your Windows system or System32 folder. And they are standard libraries, either that or libraries copied by an installer, which multiple programs can use. So programs can load libraries from that location dynamically when they run. And it's also the case that if you put a DLL file in the same folder as your program in Windows, Windows will find that DLL file there. On Unix or Linux, or Mac as well, dynamic libraries, they have a suffix usually of .so, and they also start with lib usually, so we'll have lib xyz.so. And finally, on only the Mac, dynamic libraries can have the suffix .dylib. So I guess that will be xyz.dylib. I don't think there's any lib suffix there, if I remember rightly. Prefix, sorry. So we've got DLL on Windows and .so basically on Unix or Mac. And on the Mac, there's also this dylib suffix for a dynamic library. That's also possible. So the upshot of this is that we're going to be using an API called STL, and you can use other APIs, which I'll talk about a bit in the next tutorial, to follow these tutorials if you want to. But we're going to need an external API to provide us with some graphics facilities, and depending on your system, you're going to have to locate the right kind of file to compile into your program. So one thing I should mention is that it's possible, although I said that static libraries contain actual code that's actually linked with your program, it's also possible for them to contain kind of stubs that just tell your program to load code from a dynamic library. So a common thing to do is to link your program with a static library, which basically instructs your program to find code from a dynamic library, so that when you distribute it, you have to distribute a dynamic library with it, even though you've linked it with a static library. So the static libraries, they don't necessarily have to contain code themselves. They can just contain information about where to find code, basically, for the program. So in the next tutorial, we're going to start taking a look at STL, and with this information in mind, I'm going to explain what you need to find to compile a basic STL program. So that's it for this tutorial, and until next time, happy coding.